All right, let's look a little deeper into this, and we're going to start with a real simple example. This is actually not a polynomial inequality because the x is to the first power. It looks a lot like one of the factors though that might show up in a polynomial inequality. So let's just think about this for a second, maybe in a way that we haven't. So maybe the first thing if we want to think about with this is, we would ask the question, and this is the same first question that we ask with polynomials. Where does this thing equal 0, right? We want to figure out eventually when it is greater than 0. But we want to first start by figuring out when it equals 0. Now clearly this one equals 0 at 4, right? So x minus 4 equals 0 at 4. Okay, so that's simple enough. But the point I want you to notice is, what about over here? What is it? What is it? What kind of values do we get? So for instance, plug in a 3, right? And if you plug in a 3, you get a 3 minus 4, which is a negative value. Plug in a 2, you get a 2 minus 4, which is a negative value. So over here, we're just going to put a big negative sign. So to the left of 4, or less than 4, x minus 4 is less than 0. Now what about to the right? So now we might choose something like 5. 5 minus 4 is a positive 1, maybe a 6. 6 minus 4 is a positive 2, and so on. And you notice that for all of these values, we're going to get a positive value out of the expression x minus 4. The point I want to make is this. At where the expression equals 0 forms a dividing line, and on one side of that dividing line you're going to end up with negative values for the expression. On the other side you'll end up with positive. Now they could be swapped, right? It could be positive on the left and negative on the right, but the point is it swaps signs at that particular factor. Now the only time this wouldn't happen is if that factor was repeated, okay, an even number of times. But if it's just a single factor like x minus 4, then just in your mind you can understand how that one factor works, how x minus 4 works. At 4 is the dividing line. One side of it is positive, one side is negative, always. And so we're going to use that to look at a at kind of slightly more complicated example of solving polynomial inequalities, and demonstrate another method that we can use to solve them. So here's our inequality. Solve x squared plus 3x minus 5 is less than or equal to x plus 3. Right? So there's the inequality, and we see that x squared there, which tells us we're going to have to use this factoring method. If there were no x squared, it would be a linear inequality, and we would just isolate the x or solve for x. All right. Now this problem illustrates one thing. I'm going to change this real quick to just one thing. I don't want this less than. Let's make this greater than or equal to. Okay. So in this problem, the very first thing you need to do, and we didn't have to do it in the other problem, is we want a big fat 0 right there. We want that to be 0. So we need to move the x and the plus 3 over. So we'll subtract an x from both sides. And we'll also subtract a 3 from both sides. And so when we do that, we end up with an x squared plus 2x minus 8 is greater than or equal to 0. And now we're ready to solve this. We know what our first step is to solve for the zeros. Set it equal to 0 and solve it by factoring. And so we get the zeros of x equals negative 4 and x equals 2. Now I want you to take a quick look. We've got x plus 4 and we've got x minus 2. Okay, just think back to what we said up here. At minus 4, the factor x plus 4 is going to switch from positive to negative. At 2, the factor x minus 2 is going to switch from positive to negative. Okay, keep that in mind as we proceed. So here's how we're going to do it. Just like we did before, we're going to say, okay, put these numbers on the number line. And in this case, you'll create 3 regions, the left, the center, and the right region. We'll kind of refer to them like that. And then what we're going to do is we're going to put just our factors. So x plus 4 is one of our factors, and x minus 2. All right. Now, I'm going to put a little dotted line so I can keep these separate. Okay, let's look at the values just of the expression. Remember last time we said, hey, the next thing you're going to do is pick a test value in each of these and see if it's a solution. We're going to make our work even a little easier because we're still going to pick a test value, but we're only going to plug it into one factor at a time instead of the entire expression. All right. So x plus 4. Let's pick something in the left region, say a minus 5. Minus 5 plus 4 is a negative number, right? Now, I could go ahead and pick something in this region as well, like a 0, plug it in, or I could just remember, hey, if I'm negative to the left of negative 4, then I'm going to be positive to the right. And so I've written 2 positive signs there, but it really is just one big positive sign for the entire right side of negative 4. So as far as the signs go for just the factor x plus 4, it's going to be negative, positive, positive. Now do the same thing for 2, or for x minus 2. Remember, things will switch at 2. So let's just pick something over here, say 3. 3 minus 2 gets 3 gets plugged in. 3 minus 2 is a 1. That is a positive value. So that means at 2 it swaps to negative. So for each of the factors, these are the signs. Now, remember what our expression is the product, right? Our expression looks like this. This times this. And so the easy way to do it is just to realize, hey, in this area, I'm going to have a negative times a negative. And I know that that's a positive. In the center region, I'm going to end up with a positive times a negative, and that's going to be a negative. Here, a positive times a positive is going to be positive. And now I know where the solutions are, because look back at our original expression. We wanted to figure out, when is that thing greater than or equal to 0? Well, we know where it's equal to 0, right? There and there. And then where is it greater than 0? That area and that area. So if I were to shade this, those numbers are a solution, those numbers are a solution, and let's put this in there. We're going to include negative 4, we're going to include 2 because we've got a greater than or equal to. So we would write our solution like this: negative infinity to negative 4 together, or union with 2 to infinity. And those numbers would represent the solution to our inequality, and there you go. Now, if we just want to quickly double check graphically, then let's just look at the graph. There's the graph, right? We'll kind of make it a little smaller here. And we want to know, when is this thing, what? Bigger than 0. When is the graph above the x-axis? Well, there and there, and that translates in terms of x intervals, there and there, which are those 2 intervals we've found. And thus we've determined where the solutions of this inequality are.